I want to go a little bit further now and get rid of this sum here and produce an even nicer expression. So here's how you would do that. Again, this is what we want to compute. Now, let's say that you know that this is what you want to compute, and what you have at your disposal, you have the x, and you kind of figure that what you want to do is you want to compute this kind of thing for all the test cases. Now, in fact, you can compute it for all the test cases by just computing w transpose times x minus y, and the times here is the matrix product. So what you get, if you compute it, again, we did it, but just to emphasize the point, what you get is a 323-dimensional vector. So you get the output for all the training cases. So this at 0, this would be the predicted output for the 0th test case, because it's going to be theta dot x0. That's the same as saying dot of theta x and then taking the 0th coordinate. It's going to be the same. So let's say that you have those things, and what you have here is you have a product of the jth x with the ith entry in this guy. So this looks awfully like matrix multiplication, because what you're doing is you have a matrix x, and then you're saying, okay, what I want to do is I want to say the sum over I of xji times this guy, which is a vector at I. So what this suggests is that this whole thing is actually, if you take all the j's, it's actually just going to be the product, the matrix product of x and this thing. Now, it's kind of hard to figure out, and sometimes what you want to do is you just want to look at the dimensionalities and see if things make sense. So the dimensionality of x, again, 3 by 323, the dimensionality of this kind of thing, minus y, not going to make a difference, is this. So those match. So if you multiply x by this, you'll get sensible results. And in fact, if you say dot x, so that's not entry-wise multiplication, that's actual matrix multiplication, times this y minus dot theta x, this guy, and then you multiply it by 2, you in fact get the same as what you'd gotten if you used this thing. Those are the same thing, and this expression is, well, probably nicer. Let's copy it over here.